Ever pondered over the term recall in machine learning? Well, prepare to unravel this enigma. Recall, also known as sensitivity hit rate or true positive rate, is a key measure used to evaluate the performance of a machine learning model. It might sound complex at first, but let's break it down. Imagine you have a basket full of fruits and your task is to pick all the apples. You reach in and pull out fruit after fruit, trying to grab only apples. The recall in this scenario would be the percentage of actual apples you managed to pull out. In machine learning, recall is the proportion of the relevant instances that have been retrieved over the total amount of relevant instances. It's all about capturing as many relevant instances as possible, even if some irrelevant instances get swept up in the process. Now, you might be wondering, why does recall matter? Well, in certain situations, the cost of missing a relevant instance or a false negative is quite high. For instance, let's say we're dealing with a machine learning model designed to detect cancerous cells. If the model fails to identify a cancerous cell, the implications can be life-threatening. In such cases, having a high recall is crucial. It's better to flag a few healthy cells as potentially cancerous, false positives, than to miss a cancerous cell, false negative. But remember, recall is not the only metric to consider. It's just one piece of the puzzle. If our fruit basket scenario, if you were to blindly grab as much fruit as possible to ensure you didn't miss any apples, you'd end up with a lot of oranges and bananas as well. That's where precision comes in, another key metric that we'll touch on later. Now that you have an idea of what recall is, let's delve deeper into understanding this crucial metric. A recall, also known as sensitivity or true positive rate, is more than just a technical term. It's a pivotal metric that helps us evaluate the performance of machine learning models. But what exactly does recall mean? And why is it so important? Let's start with the mathematical formula for recall. It is calculated as the number of true positives divided by the sum of true positives and false negatives. Now, don't let these terms scare you off. They're pretty simple once you break them down. In the context of a machine learning model, a true positive is when the model correctly identifies a positive instance. For example, if our model is designed to detect spam emails, a true positive would be when the model correctly flags a spam email. On the other hand, false negatives occur when the model incorrectly identifies a positive instance as negative. In our spam email detection example, a false negative would be when a spam email slips through the model undetected and ends up in our inbox. So in simpler terms, recall measures the ability of a machine learning model to find all the relevant cases within a dataset. The higher the recall, the fewer false negatives there are, meaning the model is good at catching positive instances. However, it's important to note that a high recall doesn't necessarily mean our model is perfect. It could also mean that our model is flagging too many emails as spam, including the ones that aren't. But that's a discussion for another time. To sum it all up, recall is a crucial metric that tells us how good our model is at catching positive instances and avoiding false negatives. It's all about finding the right balance and ensuring our model isn't too lenient or too strict. With the formula in mind, it becomes clear why recall is such an integral aspect of evaluating machine learning models. You might be wondering, if recall is so important, why not just optimize for it? Well, that's a great question. It seems logical, right? But here's the catch. In the world of machine learning, there's a delicate dance between recall and another crucial concept known as precision. You see, recall, as we've discussed, is about capturing as many positives as possible. It's like casting a wide net to catch all the fish in the sea. But what if you're only interested in a specific type of fish? That's where precision comes into play. Picture precision as a finely tuned fishing rod. It's designed to catch only the fish you want, leaving the rest. So, in machine learning terms, precision is about how many of the items we identified were actually relevant. It's the proportion of true positives to the sum of true positives and false positives. Now you might think, great, why don't we just optimize for precision then? Well, here's the thing. If we focus solely on precision, we might miss out on some positives because we're being too selective. It's like only using a fishing rod when there's a whole school of fish you could be catching with a net. In other words, optimizing for recall can lead to more false positives, while optimizing for precision can result in missed positives. It's a trade-off, a balancing act, if you will. But why is this balance so important? Well, depending on your project, the cost of missing a positive might be far greater than the cost of including a few false positives. In other cases, the reverse might be true. It's all about understanding your specific situation and adjusting your approach accordingly. So while recall is important, it's not the only metric to consider. One must strike a balance between recall and precision. It's like a perfectly choreographed dance where each step complements the other, leading to a more accurate and efficient machine learning model. Enough of the theory. How about some real-world applications of recall? Let's take a look at medical diagnostics. Imagine a scenario where doctors are looking for a rare but serious disease in patients. In this case, the cost of missing a positive, which we call a false negative, is extremely high. It could lead to serious health consequences for the patient. Here, a high recall is critical as it ensures that all actual positive cases are correctly identified, even if it means a few healthy patients are falsely identified as sick. Now consider the world of email. We're all familiar with spam filters, right? These filters use machine learning algorithms to separate the junk from the important stuff. In this case, recall is again important. We'd rather have a few legitimate emails wrongly classified as spam, false positives, than let a single spam email sneak into our inbox, false negatives. A high recall ensures that all spam emails are identified, even at the cost of misclassifying some good ones. Lastly, let's discuss fraud detection. Banks and financial institutions use machine learning to identify fraudulent transactions. Here, a false negative would mean a fraudulent transaction goes undetected, potentially leading to significant financial loss. Therefore, a high recall is desirable to ensure all fraudulent transactions are caught, even if it means flagging some legitimate transactions as suspicious. In summary, recall is all about minimizing false negatives. It's about ensuring that all true positive instances are identified, even if it means dealing with a few false positives. In many fields, this trade-off is not only acceptable but necessary. In medical diagnostics, it could save lives. In spam detection, it could save us from those annoying junk emails. And in fraud detection, it could save us from significant financial loss. As you can see, recall can have real-world implications and can be a critical factor in many fields. So, to recap what we've learned about recall in machine learning, let's revisit the main points. We started with the enigma of recall, the ability of a model to find all the relevant cases within a dataset. We then broke down its intricacies, exploring its formula, which involves calculating the true positives over the sum of true positives and false negatives. We also discussed the delicate balance between precision and recall. Remember, precision is about how many selected items are relevant, while recall is about how many relevant items are selected. It's a constant tug of war, a balancing act that requires careful consideration. Finally, we delved into some practical applications of recall. It plays a crucial role in fields where missing a positive instance is not an option, like medical diagnosis or spam detection. Understanding recall helps us evaluate the performance of machine learning models more effectively. So, next time you come across this term, you'll know exactly what it means.